Okay, let's learn about Solidity primitive data types. Especially we are going to look at integers, booleans and addresses. Okay, let's create a new Solidity file. I will name it data types.sol. So like this, I will remove those stuff, and first we have to add the license identifier //spdx license identifier and MIT. Then we have to mention the version, so it will be pragma solidity 0.8.30 or 30. Then we have to create the contract. I will create contract and data types. The contract name is data types. Okay, let's first learn about integers. In most languages, you just say int for integers. In Solidity, we have to be more specific. We have two main categories. Let me create a comment, and the first category is uint and the second category is int. Let's first talk about uint. Uint means unsigned integer. Unsigned integer. So unsigned means no negative. No negative sign. It only contains the positive numbers, which will start from like 0, 1, 2, 3, so and so. So with uint we don't have any negative numbers like -1 or -22. It only contains the unsigned or positive numbers only. So now you may think, why do we have this uint and int in Solidity? And you may learn other languages like JavaScript, PHP, Java or C or anything. You don't see specific data type for positive numbers. But why on Solidity? The reason is simple. Because you can't just have minus, let's say 5 Bitcoin in your wallet. For money, we almost always use uint. And in the other hand, we have integers or int, which means signed integer. Signed integer. Sorry. This can be negative or positive, like -5, 0, -10 or 12, 10 and 10 or 12, or like we have both negative and positive in int. So now you may think, if we don't need minus values for money, or we don't use minus value for money, why do we have minus? Because we can use the minus value for things like temperature on a weather app or coordinate on a map. So we must have signed and unsigned integers. Then we have to consider about the size. When you start to build apps or start to work on Solidity, you will always see numbers next to the uint or int, like uint 8 or uint 256 or int 16, like this. So this represents how many bits of memory is the number take up. So uint 8 is the smallest. This will be range from 0 to 255. And then we have uint 256, and this is massive, and it is the standard. So in Solidity, if you just type uint like this, it will automatically default to the uint 256. Like this is equals to uint 256. So I already forgot to tell, here we add comments. Those are just comments, so I use the comments to add note. And I think I already told about the comment. So this is the single line comment, and we can add note or instructions here. And also we have double line comment like this. So inside here we can add stuff like this. So I hope you already know about the comments, and if you don't, now you know. So I will remove this comment, and let's again go here. This uint 256 is the most gas efficient type. because the EVM designed to process 256 bit at a time. So now you may think why we need uint 8. That's because let me create another comment like this, or let's make a double line comment like this. So why do we need this uint 8 or uint 16? Because we can save the storage space by using small bit size variables. Also we can use it to limit numbers. So in real life example, let's think you need to create 10 integers, or you have to store 10 variables on blockchain. And when we talk about blockchain work as a specific database. So in Web2 language like JavaScript or Java, they specifically connect with the database on relational or non-relational database like SQL database. And blockchain, it save data on the blockchain, and this data can't be changed and it's immutable. So when you think of Web3, you have to always understand this concept. Blockchain is a shared ledger that we cannot change, and it doesn't have a central authority, which means so when we save 10 numbers to the storage, it will take lot of memory if we save them in uint 256. But if we save them in uint 8, uint 16, it will not take much space. And I forget to mention, if that variable has only number between 0 to 255, it better to store in a uint 8. I hope you get that concept. And now let's delete this, and no, let's keep it, and let's declare our first uint. Okay, here I will just create uint 256, and here I will add public, and let's make our variable name as max amount, and let's add max amount as 100. So here is our first uint 256. And also let's create another number. So I will create it as int 256, and this will be also public. And let's make this variable name as current temperature. I think the text is correct. Let's make it as -5. And now we have two int and uint variables. So if we compile, we got the green check mark. And if we here add -100, and here you can see the error sign that say you can't add signed literal to unsigned type. Okay, let's remove it, and let's make this 256 to like 8, and here I will add 256, and it also have error when we compile it. Here it say type in const 256 is not implicitly convertible to expected type uint. So because we can only add 0 to 255 or 255 to the uint 8 data types. And here is all about the integers, and let's talk about booleans in the next lesson. Before we go, let's compile and deploy this to our Remix VM. I will go to deploy and run transactions because we get this green check mark on the compiler, and I click on deploy. Here we go. Here we have the buttons. First we have max amount, and I click on it, and here we got the number, and here we have the current temperature, and it's -5. Okay, we have successfully stored the integer data type, and I will see you in the next lesson.